Hi everyone, this is a demo for Vocal Team Sprint 3 progress update. So the first thing you'll notice looking at our application is our redesigned user interface. At the end of Sprint 2, we showed a very simple UI that demonstrated the capabilities of our pitch detection algorithm, and it worked by capturing samples of audio from the user, feeding it through a pitch detection algorithm, and then displaying the name of the note on the screen. So now we've taken a big step forward in our UI design and tried to take a big step closer to what the final product is going to look like. So the first thing you'll notice in our new UI design is that we have a title at the top where we say exercise 1. That is the name of the song that we're going to sing. In this case, this is one of our exercise mode songs, the first exercise, as a matter of fact, and we've called this to be part of the vocal beginner series. Normally, you would have an artist name there, and so below that you see a series of horizontal lines, and next to those horizontal lines are note names. Now, as you'll see in a couple minutes, as we go and play a song, this interface will look very similar to Rock Band if anyone's played it. You'll see music notes scrolling in from the right-hand side, and then as they intersect the vertical line that you see, that's when the user is supposed to sing them. Now, as I'm talking, you're also seeing a triangle show up every once in a while on this scale, and that's actually neat that that's happening, because that's a point of functionality that we were going to point out. So the triangle that you're seeing pop up is the pitch feedback. So rather than show the note name of the pitch that's being sung in a separate text field on the user interface, we found a way to integrate the pitch feedback into the music note display. So right now you're seeing a little triangle pop up at the bottom of the screen, and the reason it's popping up at the bottom of the screen off of the note display is because I'm talking at a frequency that's decently far below an A3, which the frequency of an A3 just happens to be 220 hertz on the 12-tone equal tempered scale. And so this note display goes all the way from A3 up to E5. E5 is approximately 660 hertz, and that's a nonlinear progression of frequency, and our software handles the conversion to music notes. So as the user sings a note, they'll see that triangle move to the note that is whose pitch is being detected. And if it's the case that the software detects a note that's outside of that A3 to E5 range, you'll see our little triangle pop up offset from the horizontal lines, just to indicate that what it's detecting is out of range. So before we go and show you the full demo of this app, we can demonstrate really briefly some of its pitch detection performance. So because I'm not going to have you all listen to me attempt to sing these notes, which I would certainly fail at, I'm instead going to play these notes on a piano. And as the app doesn't care too much whether it's a piano or a person singing, it seems to do pretty well detecting what the notes are. So for this demo, that's going to be how we're going to proceed. So I have a piano set up, and I can just really quickly play you a couple of notes and show you that the app is able to detect them. So I'll start off with playing middle C, C4, and we'll see if it detects it. Okay, so we've seen that the app is able to detect the C4. Why don't we try another one? Let's try playing G4. Okay, and right there the app is able to detect it. And now just for fun, let's test the limits of the pitch detection. Let's try to go all the way up to E5 and see if we can hit it. Okay, so we've hit it. Now let's try playing a note beyond E5 just to show that the functionality is there. So this is a G5. Okay, and as I described before, we plot that feedback above the topmost horizontal line just to indicate that it's off the scale. Okay, and we can also try an A3 just to show that that works. Okay, so that's more or less how the pitch detection feedback works. We think it's sort of a creative way to integrate the feedback, and we put a lot of thought into how this should behave, and we tried to make it equally appealing to those that are familiar with musical notes as well as those who aren't. The experienced user can see, okay, here are all the note names that I'm singing, and then tie that up to maybe even some printed music that they're trying to sing. Whereas the inexperienced user still sees the natural vertical progression where higher pitched notes are higher up on the scale, so they need to sing at a higher frequency. So there's something there for both the experienced and novice user. The only really only other thing to point out with this interface is the seek bar at the bottom. Right now, it will behave very much like a music player, although right now there's no seek functionality. You can't click a location on the bar and have the song seek to that position. That is something we will look at implementing later. Right now, it just shows where in the song the playback is. Play button at the bottom, self-explanatory. And then also we've implemented a very rudimentary scoring algorithm. And the way that the scoring algorithm works right now is, regardless of the duration of a music note that the user is supposed to sing, if that user is able to sing that note for even 1 instant, they get credit for it. So in the series of notes that are played, when I click the play button, as you'll see in a moment, I'll intentionally hit a few notes and I'll intentionally miss a few, just so you can see how the interface behaves when I hit notes and when I don't, just to show that the scoring algorithm is functional. The one other thing to point out before we start is that you'll notice, as we're playing this song, the color of the notes that are scrolling horizontally will change to indicate that I've hit them. So you'll see the notes scrolling horizontally as a gray box originally, and then if I happen to hit the note, it'll turn blue to give some visual feedback to the user. Okay, so without any further ado, let's go ahead and get started. So I'm going to click on the play button and then attempt to follow along playing these notes on the piano. And I'll skip this one. Okay, so you just saw our demo. You see that we intentionally missed a note, so our score is only 88%. Thank you all very much for your time.